All right, scholars. As we get set to wind down our rational function exploration, to date we have discussed and examined the end behavior of rational functions and the more efficient manner to identify that end behavior using the degree of the numerator and denominator. So for the last three lessons, we're going to look specifically at how do we solve rational equations algebraically and how can we make sure that we don't include solutions that aren't necessarily a part of the domain? So, without further ado, I'm going to go into the next slide. In these four examples here, you have four different equations. Two are rational, two are linear and quadratic, and you have a particular x value. You should notice that the x values are consistent, except the equations are quasi-consistent. There's similarities, but there's obviously apparent differences. So write down two things that you notice, two things that you wonder. Let's get some discourse going amongst our peers and jump into the next activity. So at school, we have the art club who is designing and printing T-shirts. A local business is going to charge them $35 to set up shop and $4.25 in materials per T-shirt to print. You're supposed to create an equation to represent the average cost per T-shirt if X T-shirts are printed by this business. I want to take a moment here to remind you that when you're calculating the average of anything, it could be the average cost, the average sales, the average of a data set, the average of weights of professional basketball players. You must divide by some quantity. That quantity, in order for a function to be defined as a rational, must be a variable. That should give you pretty sufficient advice as to what your function should look like. So it must be rational, and you must have a variable quantity in the denominator. After you do that, you'll use your function to determine what is the cost for 25 and 100 shirts. And similar to what we did in lesson 11, where we had a graph to kind of justify our values, it is your job to algebraically determine what is the cheapest the average cost per t-shirt will become. So you most likely, hint hint, need to do some or perform some type of algebraic manipulation so that we can better identify the end behavior. Okay. And then after that, and I'm not going to give too much detail here since I would like to see what you're able to come up with. You'll need to use your cost function to determine how many shirts you can print that have an average cost of $5 or less. So be mindful in solving or simplifying that type of equation. Not going to really give away the solution path with my vocabulary. I will assist here though, because I know many people may not be necessarily aware of baseball. So Carl's on the school baseball team, and he has had 24 base hits out of 110 bats. To calculate the batting average, right, he's obtained 24 hits out of a total of 110. So he's currently batting a whopping .218 or 21% of his at bats. That's not really good. So, unfortunately, Carlos gets no base hits in his next three at bats. Revise your equation and then calculate how many of his next consecutive at bats need to be hits to raise his batting average to 300. Explain how you revised your equation and each of your solving steps. So, taking Carlos' initial batting average, which was 24 out of 110. He did not hit the next three attempts, so he's currently 24 out of 113. But he is hopeful to raise his batting average to 300. To do so, he would need consecutive at bats where he continues to get hits. So if he obtains a hit right, in his next at bat, he would have 25 hits out of 114 at bats. If we replicate that process, right, and he gets a hit again at his next at bat, he would have 26 hits out of 115. So algebraically, I want to make sure that I add x, meaning consecutive at-bats to his current batting average. And then algebraically, I need to reverse or undo the current structure of this equation. So I have a rational function. Rational functions implicate division. What is the opposite of the division? I'm going to leave that for you to algebraically solve because that's where we're going to pause. So I'm interested to hear how many consecutive at-bats Carlos needs. Hopeful that everyone has the same answer, but staying realistic and looking forward to a excellent class discussion.